Everything Electric Canada in Vancouver is one of the biggest exhibition and discussion panel for electric cars and transportation in general. Although no Aptera vehicle was displayed at this year's show, it was present in several panel discussions. Sandy Munro from Munro & Associates, Steve Fambro from Aptera Motors and Jack Scollett from Fully Charged, who visited Aptera in Carlsbad before and actually drove the Aptera Gamma vehicle, made sure that it was in everybody's mind. Before we listen to Steve Fambro being interviewed by Sandy Munro, let's listen to a few snippets of other panel discussions. Let's start with how and why efficient electric cars make everything better.
For purpose. But let's talk, Ken, about car design and engineering and how you build an efficient electric car. Somewhere in this hall, there will be two EVs with the same size battery, and one of them will be capable of going sub 100 kilometers further than the other. Why is that?
Yeah, it's a great question. I mean, things like aerodynamics, weight, the amount of power output, the size of the battery, they all contribute to the efficiency of that vehicle that you'll get from the electricity stored in those batteries.
Yes.
How they manage the power, all those things are extremely important, much more important than an internal combustion vehicle. And again, most of the manufacturers are making vehicles now that consumers could drive that have very low drive coefficients. Part of that reasoning is because of getting every ounce of energy out of that battery that you can. And then also developing batteries that are denser, that will be able to hold more charge in that same footprint. So you only have so much room to put cells within a car frame.
Yeah. Now, it's certainly true that many car brands are being slightly lazy in the way they engineer their cars. They're giving them huge batteries in order to achieve big range instead of doing it the clever way, but not all of them. And I'd like to shout a few out, Ken. Tesla continue to be basically the best in the world at getting big mileage out of batteries, except for maybe Aptera. Do you want to talk about those guys?
Yeah, I mean, Tesla, that's all they do is build electric vehicles. So they really set the bar or the gold standard that a lot of others look at. They've just been able to make it an art form on battery management, on efficiencies, aerodynamics, and pulling all that together to provide very efficient and one of the most efficient vehicle lineups that are out there. But you mentioned Aptera,
no fake grill,
very low coefficient, teardrop type of design vehicle that will claim, I think, up to 1,000 kilometers range in some of their models. So, and still hold a couple of people and some stuff. So you've got, both ends of the spectrum that you could do from an engineering, from a design, and all the specs that go into the batteries and everything is part of that. So there's a lot that you can do. I think the average consumer, what you see on the floor today, lasers, SUVs, pickups, they still have some aerodynamic treatments and they, flat bottom floors. All these little tricks will have extend ranges.
Yeah, someone once said to me that Aptera is what would happen if you had a car brand with no designers, just engineers, which I think is a little bit hard. It's actually really pretty, but I do see where they're coming from. It's a remarkable vehicle and a study in hyper efficiency. That's what that car is. It's all the principles that we're discussing on steroids. It's a really wonderful thing.
Let's hear what some experts say about the right to repair in the electrical vehicle business of big, rough, tough jobs, but also what Aptera Motors' approach is.
It's a really good point. I made a video about farming a couple months ago and I was blown away. The number one comment by far was about the right to repair, which is important for all of us. I think it's an important thing as consumers in general. But if you're a farmer, if your livelihood is razor thin margins, it's just so important. Chase, how important is that going to be? We're early in this stage for electrifying some of this bigger stuff. How big a role is right to repair?
I think honestly, right to repair is a huge issue going forward to make sure these trucks stay on the road as long as possible. If you look at the environmental, we're going electrification. One of the reasons is for environmental reasons. Well, what environmental benefit are you getting if the truck can't be fixed? You got to throw it out in 4 or 5 years and buy a new one. It used to be you could buy a logging truck, keep that logging truck on the road for 20, 30 years. And now I'm seeing a trend I don't like where we're going electric, but people aren't allowed to work on their electric. A lot of the people here have either built their own electric vehicle as a hobbyist or worked on something, and they know that electric is simple. I think electric is way simpler than an 18-speed transmission. You ever looked inside one of those things? You see it is like when we load logs into the mill, we were unloaded by a diesel electric lateral log loader. It was an electric log loader made in 1967, and it still unloads 200-300 logging trucks per day. The thing just works. It's reliable and it does the job. There's no reason that electric cannot be reliable. And you see the things, well, we don't want anyone else to work on it because it's got live batteries. It's dangerous. Like, we only have our technicians because of the danger. You know what else has live power? Every sawmill in North America has live power. It's got 3-phase power. It's lockout tagout procedure. Yes, there'll be a few things that mechanics have to learn, lockout tagout, but it's learnable. There's no reason that you can't teach somebody how to work on these electric vehicles. We should get to the point where an owner-operator should be able to fix his truck. We've proven that we could build that truck with parts that we found off the shelf, basically in Merritt. There's no reason that you can't have that anymore, where you can't walk into the local parts store, grab the part you need, grab the contactor you need, the brake pot you need, throw it in there and get back to work. And it's so much more important in the trucking industry than it is for the passenger cars. Your passenger car goes down for a day, maybe you can rent a car. That logging truck goes down for a day because it needs a part that's hard to get. That's $3,000 a day that you're losing for those 2-3 days. Being able to repair is going to be so crucial to get electrification adopted and moved into mainstream.
You know what? I am such a fan of right to repair. I've had arguments with the guys at Tesla. I've had arguments with everybody.
When I was talking to Arthur Erickson, not the architect who's local to here, he is the founder and CEO of Hylio Aerial Drone Spraying and Seeding. So he's got the 14, he's the North American manufacturer that. Right to repair is a big sales feature for his drones. Because you can wrench a drone, even a 14-foot one, by the side of a field with a simple set of tools to replace blades and stuff like that. And they don't have to use the tractors nearly as much. And so it becomes a sales option, something that's really helping that technology disrupt the farming community from the underneath.
Nice. Ralph, go ahead.
Actually, aptera is a right to repair company at heart, and they're going to be putting actual QR codes on every part that you scan, and they'll go to a how-to video on how to buy replacement parts. That's how far aptera is going to do is so tutors respect the right to repair.
Talk a little bit about aptera or some of these cool initiatives to make it easier to actually find parts and fix stuff.
I don't want to turn it into a mic hawk, but I know quite a bit about what's going on with aptera. And so Steve and Chris hired Monroe and Associates, and I've actually put money into that company, which gives me the right to talk a little bit about what I thought was the right thing to do. And right to repair with the two guys that own the place, they're on board. I truly believe that that'll be an advantage as well. But at the end of the day, what are you going to repair? Virtually nothing. Maybe if your headlight goes bad or something. But at the end of the day, this thing is so simple and will basically run forever. So I'm pretty sure that you won't need to repair much, but if you want to, you can. And I believe that, like you just heard from Michael here, that is a selling feature that's going to make a huge difference out there.
Now let's hear from one of the founders of this study in hyper-efficiency.
Okay, so thank you all for coming this morning. We're going to start a little bit early, so hope you don't mind. So that'll give us more time to hear a little bit more time to hear about what's going on with aptera. So I'm going to introduce Steve Favreau. He is a co-CEO, correct? I think that's what it is. Anyway, let's sit down. It's going to take a long time. So, yeah. So, Steve, why don't you give us a little bit of background on where you came from, what's going on? How many people here know who aptera is? Oh, not many of you. Eh? Lots. Okay. So, sounds like you've got some slide to do. Let's see.
So my name's Steve Favreau. I was born and raised outside of Atlanta, Georgia, Temple Ripville, and I started working on cars, anything with a gas engine, as early as I can remember. Even before I could drive, go to bike, I worked as a mechanic at a local VW repair shop, which was also a gas station. So I learned everything about the automobile. Almost everything you need to do is with a 10 millimeter or 25 millimeter socket, and began rebuilding engines. Just worked for World War cars. And after high school, I decided to join the Army so I could learn some kind of trade, some way to be primitive. That took me to Germany and around the world. And I got out of the Army. I said, go work on stuff, go to build stuff. So I went to school on the GM Bill and got my BSCE, Bachelor of Science, Electrical Engineering. Got hired in biotech at Illumina in 2001. And that was a lot of fun. San Diego, got to make robots that make DNA that sound a lot more complicated than it is. You really just mixing 4 different chemicals and agents. But it was around that time that the idea for Aptera started in me. And it was not to, I wanted to know the art. I didn't want to know something fast. I didn't want to do something that already been done. And I wanted an electric car. And at the time, you can only convert an electric car. You couldn't buy one. And so when I started meeting with people that were converting them, I saw that they were getting 20, 30 miles range. And I thought that was absurd. Why is that? And of course, I go straight to MATLAB and I go straight to, books and everything else. And I discovered a couple of things. First, battery density, energy density sucked. At the time, lead acid was really the only kind of battery people could use conversions. But I also discovered that cars use more than half the energy just to push the air out of the way. And that's just a result of the design process or the styling process. Cars, since really the time of Charlie Earl, have been made like furniture. They're designed as styling exercises. And so I thought, if I'm going to make an electric vehicle, it has to be the lowest drag possible, has to be the lightest weight possible. Otherwise, I'd be stuck with 20 or 30 miles range like these other converted cars. And so that was really the genesis of Aptera.
Oh, it's cool. And that was very interesting. Okay, now when can I get one? I guess we just jump right in. Yeah, when did they we're going to be, or give us the production plan, maybe, is the right way to do it.
I mean, of course, because we've been working with your company to develop this vehicle for a couple of years now. And everything that the people have seen at the different levels of prototypes, alphas, gamma, the beta, the green car that, drag raced the Audi R10. And all of those are various forms of prototypes. We're building the first pre-production vehicles, or what we call PI builds right now, actually starting Tuesday. PI stands for production intent. And that really spans the spectrum of validation prototype, design validation, durability testing, and all the other different validation testing that we have to do with airbags or suspension or braking. Those are all production intent cards and systems, about production intent geometries, and basically a production intent vehicle. So that's what we're building now for the first time, started this Tuesday, with a team from Italy, team of 4 arrives to help us with the very first beam or carbon body construction. We've got the materials, so the frame that you've seen, it's machinists of the past, because it's part of the production intent geometry, not production intent methods. But we got production battery, production BMS, production powertrain, production low voltage, zonal architecture. All those production things will be on this first vehicle. It's already had its first milestone of bench function, so we've been able to put it in drive and reverse on the bench with all the systems working on the bench. And now we're waiting for the body to be built, so we can take everything for the bench, put in the body, and then we'll drive around PI2, which will be the first production 10 vehicle. I should have it by the end of this month.
So one of the things that you decided to do that personally I wouldn't have done, but you decided to take a auto cycle, which is a 3-wheel vehicle, and it has the same restrictions as a motorcycle, which means there's no airbags needed, there's no seat belts needed, you have to wear a helmet if you drive it. But you decided to turn it into a real vehicle. So I guess you should be commended for that. That'd be wonderful. But what drove you in that direction?
Well, we want it to be as safe as it could possibly be. And so that means a couple of things. It's got to have seat belts, probably needs to have airbags, needs to have a root crush strength that's comparable to the FMVSS of a passenger car. So there's some basics that we took from automotive FMVSS and said, we're going to do that because we think it's above and beyond what's necessary to make a safe motorcycle. Certainly not a passenger car, but we felt it was sort of the minimum that we would want to have ourselves if our children were driving or riding in it along with us. And that was really anticipation. Yes, I think we could have made a much more austere, decontented vehicle, but we probably wouldn't have wanted to drive them every day ourselves or let our spouse drive it.
Well, I probably would have drove it. So anyways, you mentioned Italy, and Italy is one of my favorite countries right now because it has my favorite die casting company, which is Costam. They're the guys who do all the molds for Tesla. All those giant cast molds that I talk about or shown on in my videos. All those dies come from a place called Costam. And also in Italy is another company called CPC that was recently just sold. So they went from independent ownership to now being part of Mitsubishi. So I'd like to touch a little bit on the manufacturing of the castings for your suspension system. Let's do that one first, and then I'll go crazy. We'll start talking about carbon fiber, the new steel, and sure.
Well, when we first took our design to Italy, we could talk about why we went to it in the first place. Later, we're talking about CPC. CPC is sort of the anchor for us, helping us make high volume composites. The composites we were making back in California, there's no way they could scale to keep up with the orders that we had. We had to find something different. That's what took us to Italy. That's how we discovered CPC. CPC is connected with a network of suppliers that they work very comfortably with to provide products, for Ferrari, Lamborghini, Maserati, others, well-known companies, agriculture companies, and they're have a very tight-knit relationship with these companies. And so when they looked at our needs for strength, materials, et cetera, for the chassis, they immediately thought of Costam. Costam will be the one that could provide us with these castings at a reasonable cost with the quality that they've had experience with, so that when they model the part and crash simulation, multi-body analysis, they know exactly how it will work because they've done this many, many times. So Costam has basically taken our original concept of the frame and chassis, which the cargo body mounts on, and they made it producible with low pressure casting. So it's not high pressure casting and the giga casting. We don't need it. Our vehicle doesn't have those kinds of stresses because it's a 2,000 pound vehicle, not a 5,000 pound vehicle. But we get a lot better quality product than with sand cast. And so it's amazing to see them because they're nestled right, at the base of Lake Como in Italy. So you think how on earth could a company in Lake Como of all places, a stone's throw from George Clooney's villa, how can they compete on the world stage for cast assembly parts? But they do. They were packing up 1,000, 5,000 things of a thing they were making. I was mentioning to you that's going, somewhere in Asia. And the company who ordered them and did the calculus is it's actually better and cheaper to make it in Italy than to make it closer in China. So that, tells us something. It's like they're really good. Costs are good at what they do. Make a very good product. And they've got a great working relationship with all of our other partners in Italy. But CPC was an anchor for us to connect them. As I mentioned, we were getting pre-orders faster than we could imagine. We thought we'd get 1,000 or 2,000 for the year. We launched a company, we got 1,000 or 2,000 first week. So we said we need a different way to make this vehicle. And that's what led us to CPC. And I would say they've got immense experience that they've leveraged with other manufacturers, white labeling other products that probably most people don't realize. And they open up this ecosystem in Italy to us that we were really unaware of, where like car culture's in the blood. People grow up wanting to work in the car industry there. And the wages are very favorable. The steel is very favorable. The work ethic is fantastic, especially in that part of Italy. So it's been really great for us.
Yeah, I can mention a little bit about who does use Italians for especially for low pressure castings. And that would be Ford Motor Company. When I was still working for Ford at Engine Division, I sourced everything. All my cylinder heads that were really, really complicated, they all went to Italy. It's not something that everybody knows about unless you're in the business, and that's where things really make a difference. When you find an organization that can build basically anything you need, and they do it at a great price, like you're mentioning the engine, that's a monoblock engine being manufactured at $5,000 products per month. That's pretty big, and that's a real feather in the cap for CoStam. And so they actually make the molds and dies. They also shoot product, right? And
yeah, they make the molded dies for that other big car company we're talking.
Yeah, that would be tough. So, anyways, at the end of the day, I think that getting the castings and whatnot from Italy, that was a genius move. And now what we need to do is talk a little bit about the carbon fiber body, because the body on the Aptera, from a sheet metal standpoint, I wouldn't even quote the job. That would be a no vote for me. But with carbon fiber, using SMC stands for sheet molded compound. So what I'd like you to do is maybe talk a little bit about CBC and how they're manufacturing the we'll call it, some people call it black metal, some people call it the new steel, but it's carbon fiber. Not like what you'd find on an airplane where it's hand laid up. In this process, you put it in warm into a mold. It comes down, molds it, clips it, trims it, then comes back up and it's done. It's really quick and very little waste. And what waste you do have is recyclable. But why don't you tell us a little bit about your experience with the folks over at CBC?
Sure. Well, looking at that carbon process, let's start with materials. I think that'll take us to the Middle East, but it starts with oil. So first and foremost, we're not burning oil. We're sequestering that carbon into a solar electric vehicle. So that's pretty cool in and of itself. But the reason why Mitsubishi is involved with CPC and the later acquired them, because of the sheer amount of materials that's necessary to make these parts and the logistics and coordination that's required. If they were making this somewhere else, other than at the factory at CPC, that material would have to be refrigerated, stored in a cooled environment, shipped cold, otherwise it starts curing. So what CBC is able to do with Mitsubishi's ownership now, and they did this actually before they took ownership, is that Mitsubishi built a plant directly across the street. And every day they mix the material from scratch so that it doesn't have to be refrigerated and shipped. It's actually mixed on site and brought over to the building across the street where it goes into presses. And there's virtually zero variability. Why is that? Well, when you design the dies, you know exactly from the CAD, the volume in between the die, how many cubic millimeters of space there is. And so they know precisely to the gram how much material they need to measure out for each part. And they just put those blocks in the part. It goes into the press, it squeezes, comes out, goes into a trimming jig, and then goes into inventory. It's that simple. So you think about comparing out to steel. With steel dies landing, you might doubt, depending upon the dart, I don't know, several more aggressive dies, because of the different steps and all. We do everything at one press. We have the largest single carbon fiber SMC part that we ever built in the tub instead of one press. And so instead of having hundreds of tools, we have 10 tools, all to build the structural, not body wide, but body members of the beam.
So to put things into perspective, if we look at it's a big cat thing like what Tesla's putting out, and a body that's made out of sheet molded compound made out of carbon fiber, to take a body shop that has maybe somewhere around 750,000 square feet of territory that you're going to need, you could drop that down by 80% because there's so few parts. When you squeeze it down, I got one part that would come out of carbon fiber, where normally that would be perhaps, certainly hundreds of parts and thousands of spot welds. But even better than that is when you make a part out of carbon fiber, it's perfect. It never warps. It never moves. It's perfect because it's a stone. You've just created a piece of stone. Then you move that and talk about sheet metal. And as soon as you start bending sheet metal, it bends, it warps, it twists. Then you weld it, and because of the induced stresses, it wants to relax or it wants to get tighter. And again, you've got imperfections. And then by the time you get the whole body together, anybody who's been through a body shop knows that there are guys with special tools that they make themselves to bend the parts into shape. And they've also got 2x4s that give a fine tuning, if you like, to the shape. So, and I mentioned before, I'm a tool how you do it, and I know everything, every trick you could do to try and make steel bend the way you want, but it goes where it wants because there's always a purchasing agent that's found got a big savings on a coil of sheet metal that you wouldn't want at all. So it's really a great move. Aptera's made a lot of very good moves to go into what I think is going to be the next generation of car production.
Well, on the part about the carbon, just to be clear for the audience, anyone with aerospace experience, maybe thinking like an autoclaved carbon fiber part, certainly those parts would be stronger for weight basis, but they require an order of magnitude greater labor, the handling of fiber, putting in the mold, consumables, that kind of thing. The beauty of the carbon fiber SMC and the process that CPC and Mitsubishi have developed is that the materials are perfectly understood from a multi-body modeling analysis, which means we can do crash testing, we can ensure that our torsional resonance, longitudinal resonance modes are exactly what they're going to be because the material is perfectly well understood. With sandwich core composites and high-performance composites, they may produce a lighter part, but they can't be modeled as accurately. And because of the discontinuities between the foam and the surface skin, mathematically, those are very difficult to model in the edge axis. So you can maybe model up to the yield point, but not beyond that. We don't have that problem with this material. We understand perfectly, and they, of course, validated this with their other customers and other products, how this material models, which means we can take weight out early in the design stage with confidence that, we're producing a product that's going to be the requirements that we set for you.
Well, there's one other thing we haven't talked about, and that is that carbon fiber doesn't rust. You'll never get any rust on carbon fiber. It'll be around for a millennium. Like I said, you can recycle it. Boeing's been doing it for quite some time with the 787. Anytime a panel gets destroyed somehow, usually they call it anger rash. Somebody bangs into it with a truck, you have to pull that off with another piece on. Those pieces are brought back to Boeing. Boeing then recycles them and uses the fiber, the twill, and sometimes they'll use it themselves. Most of the times they sell it to the auto industries because everybody's got a little bit of carbon fiber somewhere in their vehicle. But I believe that with your product, with the Aptera product, having the whole car out of carbon fiber is just you're in the first step. You're
recycling is a good point. So this particular material that Mitsubishi developed is recyclable up to 5 times structurally. So when they're trimming the flash off the part and collecting that out, and putting it in the bins, it doesn't get thrown away. It gets recycled again. And it can be put into a structural part up to about 5 times. Beyond that, it would be a less structural part, but functional part.
And there's tons of applications for those non-structural parts. One of them being, for anybody that's into hunting with a crossbow, that spring that you have is basically made out of carbon fiber. The center pod is made out of carbon fiber if you've got a good bow. So these are things that are secondary kind of line styles, or some secondary lines, I should say, for carbon fiber. So lots of people say it's really expensive. Other people they want to throw one with the bus because always and uses oil and stuff like that. I've got to tell you something. Pretty much everybody here has got a gallon of oil on themselves. All your clothes, all your shoes. I mean, we're not going to get rid of oil. I guarantee you that. But it's very handy to have. A car that's uber light, which will give you more range, uber stylish, and whatnot. What was it? There was something that came out a while ago. The aptera has less drag than a wing mirror or something.
So the most popular vehicle in America, the Ford F-150 pickup truck. And the side gear on the Ford F-150 has about the same drag profile as the Aptera. So it's, CD multiplied by the area again. Anyways, the products, both those are about the same.
And so that's kind of a good idea because, like you said, pushing the car takes away basically about 50% of your power. You just shoving the car from here to there. Weight, aero, and friction are your top candidates. So we were talking a little bit outside, and it sounds like Aptera's got a lot of secondary interests and whatnot, using the technology that you've developed for Aptera. You got some side bets going that sound pretty, actually stunningly amazing. When you told me about the aircraft or the airplane airport tubs and whatnot, can you delve into that?
Yeah. Well, Aptera's mission is very simple. We believe every journey should be powered by the sun. And so right now, our vehicle, you plug it in at one, but you get 40 miles range per day just from plugging in the sun. Maybe in a few years, it'll be 60 miles. So maybe with improvements beyond that, in another couple of years, it'll be 100 miles. But our endpoint, where all of our engineers are marching to, is make every journey powered by the sun. But we think that's really important, not just for us, but for the world. So we said, how do we use this technology to really move the needle with other customers? And how do we bring revenue into the company before we start selling vehicles? Because that's also important. Investment is not revenue. Investment is equity. And investors love revenue. So we said, how do we leverage our solar IP portfolio, which is pretty massive, into other segments? And we launched a pilot project with, I'd say, probably one of the world's largest airlines to solarify with Aptera technology, Aptera panels and electronics, some of the ground handling equipment. And why is that important? Airports all across the world are moving to electrification on the ground equipment. And the ground equipment is some of the most polluting things they have at the airport. The challenge is installing enough chargers in the airport, having a place to charge them. You have slow-moving, specialized vehicles that can't really drive long distances to get to chargers. So what if they could charge themselves? We thought the airport is really a perfect environment for that because there's no trees and everything is in the sun all day long. And so we've got one of our tractors doing its job at Salt Lake Airport for almost 2 weeks now, and it hasn't needed to be plugged in at all. So that's all I want to say about that one. But what is public is some of the other companies we've been working with to do the same, like Polycrops, some other trailer companies. with the poly drop trailer, you could park that camper trailer in the sun and run the air conditioning, the induction stove, the lighting, all from our solar on top. And it's not just, not running to Amazon and buying a bunch of square panels and trying to drill them on the top. These are panels that we produce with our IP that let us bend nice curves that are lightweight, thin, rugged, able to withstand the rigors of automotive environment. And we're finding that there's broad application for the expertise in doing that beyond our vehicle itself, as we found with the airport equipment, as we found with calling drops, talking, maybe with other school bus companies, etc.
So one of the questions that I had written down was, how much more funding do you need? But apparently you just closed off your last round of funding here. I am not a financier and whatnot, so I just wanted to get a grasp of what's going on. So the funding round was $60 million, but you said that somehow turns into $100 million. You want to elaborate on that for the ignorant folks like myself? How do you do that?
A magical box that it goes in to build out. So basically, it unlocks the rest of the California Energy Commission grant because that's matching money, so you need money to spend for that. And it also locks up equipment financing. So you're not going to get equipment financing on custom tools, things that have no value to marketplace. But you can get financing or leasing with tools that are more fungible in the marketplace. So having that $60 million lets us, take advantage of those two things and start the low volume production. So we're technically starting low volume production now with the PI mills, these production set vehicles. But the first 100 or so vehicles are funded, by this $60 million convertible note that's then offering to U.S. capital. But it also unlocks other monies, potentially with other governments that we're talking with as well. They like to see you manufacturing, and once they do that, then things begin happening. Conversations are different than when you're not manufacturing. So manufacturing 1 vehicle, 2 vehicles, 10 vehicles is very important for us to do that. But to date, we've done everything that we have, design, tooling, everything for less than $130 billion. We raised $130 billion. We haven't spent it all. We still have a pile of cash in the bank. So I'd say probably for $100 million, we've gotten to where we are today.
So let's put that into perspective. At Ford, I was in charge of a couple of engines. That's about somewhere around 780 to $1 billion. So 780 million to $1 billion. And then when I moved into maybe a bigger job at Ford, $2 billion, about the right number to bring a car online. It's very expensive. How much? That is for basically sales funnel on that one. So let's move this into one other thing, and then there's a gentleman here that's standing here that wants to ask a question. So the first thing here is, what's the sell price going to be for this thing?
Somewhere in the 30s to the 50s. Obviously, we've got to account for inflation when we first disclose those. There's numbers that we had out there and on the website even, I think now. But, when we open up the orders, we have vehicles at the very low end, at the low. I think at the time it was 20-something thousand, the Fire in the 40s. Most people were 40,000 or higher with their configuration of the vehicle, options, etc.
So when are we going to see the delivery?
First ones, it's not going to be all 50. There'll be a handful of those. It could be up to 10, maybe. It could be 20. But that should be by Q2 of next year.
Excellent. Well, thanks. But now we have your question, and I really do apologize. I just wanted to get through all of the little notes here, but please, what is your question, sir?
Thank you very much. My question would be towards the production methods. There are companies that print rockets with 3D printing. Have you thought of 3D printing to produce submarines?
Yeah, but we are 3D printing some parts right now. Maybe not as many as we'd like to, and it's just because we're just laser focused on stopping engineering-related activities. The pencils down, no boots closed, please build a vehicle. And that's the mentality that we're in now. But I would say there are parts right now that could make it onto the vehicle in production that are 3D printed. In terms of 3D printing metal, we've got some on there now that are 3D metal printed. They're not as cost effective as cast. If I were building 100 rockets a year, I might be able to justify that. But our production intent is 20,000 units a year. So I have to look, compare the 3D printer cost to the price of a tool part. Good question.
Okay, so it says 0 right here, and that usually means get off the stage. So before Imogen comes up with a whip, I'm going to, oh, wait a minute, we have one more question. Okay, now you put me into the res. Be a charge. And go ahead.
Question about safety. Because the Aptera is 3B vehicle, doesn't have to have the same safety as a four-wheel car. I know you have airbags, but are there, have you done testing or what are the ratings on the safety for this vehicle?
We haven't crash tested the vehicle yet. We've done it in simulation many times, and so we're confident enough with the design to move forward, build the physical vehicles, and then do that crash testing with our airbag supplier. We have to do that to calibrate the airbag. The computer that fires airbags has to go through a lot of crash testing to just validate that process. But in terms of the vehicle handling, the 3 wheels versus 4, as 3 wheels, because we want it to be efficient. But if you're looking numerically to compare its margin of stability, how stable it is mathematically, it's somewhere on the order of like a Volkswagen Golf in terms of how planted it is, CG related with everything else. So I would say it's very safe and stable. And if you look at Aptera racetrack YouTube videos, you could see that validated in real life.
And then in a crash scenario, it's not been crumbed.
No, not at all. The whole new subframe that we've been designing with CoSnap is designed like most new vehicles to accordion to push that energy below the vehicle. That's what's taken us so long to get all of that right, and then to make sure that we can produce it in high volume. And then the occupants are actually surrounded by a steel safety cage inside the car body. So it's really a hybrid of this cast aluminum subframe, carbon body, steel frame, ties all the closures, hinges, door locks, everything up. So I would say you're going to be very safe in Aptera.
Thank you.
Okay, well, thank you all very much. And, yeah, thank you very much. I think we got a stage here now. Oh, very quick. Okay, already done.
How long, what kind of delay do you expect before you'll do the deliveries in Canada?
Since you're in Canada, I have in Canada. I can't give you that number and be on a public record now because I don't really know. Believe me, it's as quick as we can. But I can't tell you an exact date. I'm so sorry.